Hello, and welcome to this latest edition of DesignSpark Ask the Expert. I'm Nigel Steele, Supplier Marketing Manager at RS. I take care of the marketing activities for a number of strategic suppliers, including Eaton. And so today I have the pleasure of introducing Tony Gartledge-Warren, Senior Application Engineer, and Vasi Uranev, Field Application Engineer, Team Leader, from Eaton Bussmann to talk about the often overlooked and misunderstood role that fuses play in many modern applications. So, first of all, Tony, would you like to introduce yourself to our viewers, please?
Hello. Yes, as I said, my name's Tony Gartledge-Warren. I've been with Eaton for over 20 years now, working in technical applications. I handle inquiries from customers of a technical nature, including fuse applications, fuse selection, product support, etc. And I vary my role in terms of doing online training and dealing with all sorts of awkward issues and quality issues. And as I say, I've been here a long time, so I'm quite versed in the product line and considered somewhat of a fuse expert.
Brilliant.
Thank you.
That's good to know. And Vasi, what about yourself?
Yeah, so as you said, my name is Vasily Uranev. Nice to meet everyone. I'm a team lead for our FAE team now in Eaton Bussmann. I mostly manage and deal with the high-speed fuses, requests, projects, and solutions. So yeah, it's a very hot topic nowadays. So I appreciate the opportunity to talk about it, maybe to educate a bit wider public on the topic. So yeah, exciting.
Brilliant. Okay, thanks very much. So before we get into the meat of the discussion, Tony, why don't you tell us a little bit about Eaton Bussmann for those people that don't know?
Yeah, absolutely. Eaton, for those who don't know, is a huge global organisation, primarily for power management. They produce equipment and products for management of all sorts of power applications. And we are part of that division that deals with fuses, Eaton Bussmann series. The company is very, very well established. It's been around for maybe 40, 50 years, developing fuses all the time. And we've seen the markets change and everything expand, and lots of changes have happened. But yeah, I mean, it's very, very innovative in terms of its outlook, and we produce all sorts of products for all sorts of applications. We are the market leaders for fuse technology, and we are always adapting and moving forward with the changes in the electrical industry that we see constantly. So with that in mind, we've got so many years experience and so many long served engineers that we are absolutely experts in our field for fuse technology.
Brilliant. Okay, thanks very much. And just for the record, where do you produce the fuses?
We produce them globally. So one of our manufacturing sites is in Hungary. We've got manufacturing sites in the US, in Mexico, in China. We've got a huge Eaton facility in India. So we are global in terms of our product support and our product line. So we can service the local markets, the global market, whatever the requirement is. The main research and development is done in Burton-on-the-Wolds in the UK, which is where we're based. And we liaise daily with the manufacturing facilities to produce products as it's needed.
So thanks for that, Tony. It sounds like a really global operation. Let's expand to talk a little bit about the role that fuses play today in the designs of modern applications.
That's a good question because there's a common misconception that people see fuses as old technology, not needed or replaced with breakers or contactors. But the reality is, couldn't be further from the truth, really, because that is not the case at all. Fuses are, if anything, more required these days than ever. We've seen so many changes in the electrical industry in terms of the generation, the microgeneration, renewables, batteries, etc. And there really isn't a product that can match the performance of a fuse in such a small, compact, easy to use and cost effective package. So fuses themselves are ever changing. We have legacy product which services a lot of the industry now, but because of the changes we see, we need to protect more now than ever with product which is absolutely critical to safety when installed and protecting people and their investments. Electricity and power generation is a powerful force. It powers the world, and it's great while it's controlled, and when you're using it, it's fine. But when things go wrong, the consequences can be pretty catastrophic. So we need to make sure that we've got product that will protect against any possible faults or occurrences where explosions or fires can occur. Hence why fuses are by far the best product for that sort of protection. And the reason I say that is because they are superb at cutting off power in the event of a fault extremely rapidly, and yet giving long service life, maintenance-free service life, and very, very cost-effective and small as well. One of the issues we see is everything's getting slightly smaller, and fuses are a compact solution which will provide a very cost-effective small package, which will provide quite impressive protection when you think that in a simple power distribution circuit, you may be getting so many amps flowing normally, and then suddenly there's a catastrophic short circuit, and that current can go up to thousands of amps. Now, without a fuse, you would see a huge explosion, etc. But with the fuse, the power will just simply be switched off. There are other technologies which can do the same thing, but they are larger, complicated, not so cost effective. So we are seeing sort of increase in demand for fuse technology and adapting to different applications as time goes on.
Brilliant. Okay, super. Thanks for the explanation. That really makes sense. Talking about the fuse and the way that the fuse operates, I know from a little bit of experience about the design efforts that go into creating fuses. Could you just enlighten our viewers just to what goes into the internal design construction of manufacturing a high performance fuse?
Yes, of course. As I've said, people often think a fuse is quite a simple device. It really isn't. But in terms of its use, it is. But in terms of its design, it causes us quite some headaches sometimes in terms of the design. But what I've got is a typical sort of a cutaway here, if I can just demonstrate. So you can see the internal construction of a fuse. Now this is a 3D printed support for this fuse here, and the fuse itself would probably look more like this. Okay, yeah. So if you use a bit of imagination there, you can see the two. But if you can look at that a little bit more closely, these are fuse elements, okay? And these are the bit that people think, well, that's just a fuse wire. But you can see here, it's not a fuse wire. It's quite an intricate design.
There are multiple paths there, yeah.
There is, yes, correct. And each, so this is the conducting part of the fuse. This is where the current passes through, okay? And if you can see, there's little holes drilled in all this, well, actually punched in these elements, okay?
Yeah.
Now, those holes are there to control the arcing which is produced during the melting process when there's a fault in a circuit. So if this fuse would typically pass a few hundred amps quite happily all day, but when there's a fault, that current goes up from a few hundred amps to thousands of amps. So you can imagine that this element here, or all these elements, will get very, very hot very, very quickly. Okay, so what we do is we design the fuse element to melt in specific areas, which are these little restrictions. Okay, and this allows us to control the arcing that's produced during that process. So we are all about controlling the explosive forces that are released in a circuit when there's a fault. So these little restrictions here, they are extremely fine tolerances, and the amount of metal that is in there is very small considering the amount of current that will flow through this fuse. These little restrictions will melt during the arcing process during the fault clearing. And the fuse itself is surrounded by a ceramic body, which you can see here. And that is a pressure vessel. So as this element melts, it explodes and the pressure is built up inside. And this body here has to contain that pressure. Now, if that chamber was just full of natural air, that fuse would explode in a really quite catastrophic manner. I mean, it would cause a lot of problems. So what we do is we fill this chamber full of granular quartz sand. Now, the sand is a very specific type, a grade, and we have quite a detailed specification on the sand that we buy to fill this chamber with. And the sand is a very, very important process. So during the melting cycle of the fuse, the sand is compacted around the elements, and the heat generated from these little melting parts here is thousands of degrees. It's enough to melt the sand and cause the sand to turn into a glass material. And that glass fills the void and creates an insulator. So each one of these little restrictions becomes an insulator, and an insulator instantly cuts the power. The other thing that it does is, because the sand is very compact inside, it creates a very long path for the explosive material to go from the element to the chamber of the fuse. So it reduces the pressure by absorbing the energy. And then obviously the fuse itself has these end connections on it here and here, so that it's easy to fit into a electrical circuit. These can be varied to whatever is required. Some standard types are available, some bespoke types. And then we've got the end connections, which you can see a little bit here. So we've got the end plate and some gaskets to help contain all that energy. So that whole construction there is a very, very intricate design. And we do computer simulations and 3D modeling and whatever to come up with these designs and produce a product that's going to be absolutely perfect for the application it's designed for. And from an end user's point of view, the customer, whoever's using the fuses, when this process occurs, they will see nothing. They will just see the power being isolated and going off. And that means the fuse is a top quality fuse. It's done its job, but the process inside is quite explosive and dramatic. So you can see basically that a fuse isn't just a simple fuse. There's a lot of design goes to it. And the other thing we see is that there's so many different applications these days. We have to design fuses for those applications. So there isn't one fuse fits all. There's a lot of different types of fuses, and they all do very specific functions, which is why we've seen such an increase in demand, because this technology is the go-to technology for circuit protection moving forward in sort of most applications that we see.
Right. So just focusing on that for a second or two, what are the main segments or applications for fuses that engineers come to you for advice on?
Well, it varies enormously. We have the more standardized segments. So we would typically see requirements for infrastructure. So we get overhead line protection on the high voltage side, substation protection, through to power distribution in factories and commercial buildings. Domestic houses have fuses. The saying I like to use is, if there's electricity, there's a fuse. There just is. But as I say, we've seen a lot of changes occurring in all sorts of segments within the electrical industry. And these include a few years ago, we saw the huge rise in demand for solar power. So we see solar farms popping up, and with solar farms, you get fuses right from the panel all the way down the chain to the point where it intersects with the national grid. So there can be 20, 30 different fuses in a chain. We get wind farms, all use multiple different types of fuses. We've got hydro power generation, nuclear power generation. We have power conversion equipment. We've got rail. One of the big topics we've seen is electric vehicles. We've got the EV charging and the onboard systems. It's all sort of changing. Another one that we do is we've seen is DC battery energy storage, which is replacing a lot of diesel generators because they are more environmentally friendly. So it's important that these systems are protected. I mean, a battery energy storage system is a huge amount of power that, if it was to see a fault, could be pretty catastrophic. So we've got fuses that will protect against that. So it's huge. Yeah, it's really huge.
Brilliant. Thank you very much. Really comprehensive. So, Vasi, let's bring you in and let's talk a little bit about. Now, I've heard about high-speed fuses and high-speed fuse applications.
Yeah.
So, can you tell us a little bit about the challenges around high speed, why you would use high speed, and what are the considerations that engineers need to take into account when choosing fuses and whether or not they need high speed?
Yeah, sure. I think it can be a challenge to find the right fuse for the right application, because there are so many of them, many types, classes, and whatnot. But high-speed fuses, they are mainly based on their name, for very high-speed operation and for high-speed protection. So their main feature is they operate in the fastest way. So they clear the fault in the fastest way compared to other protection means. So we use high-speed fuses when we really need the fastest possible protection. And we need it when we protect the most expensive and the most sensible devices. Let's say it can be semiconductor, it can be batteries, it can be sometimes even cables. So anything that you can imagine, but the most, I would say, critical parts of circuits and applications, we need high-speed fuses for them. So yeah, their main feature is the fastest operation, and we expect them to clear faults in a safe manner. But people also expect from them still long service life, to replace them as rarely as possible. And really, when you start to talk with engineers, with people, like what fuse do they actually need, we start to talk about their particular application and their technical needs. And then we move towards some technical parameters and characteristics we need to know. So we definitely need to take into consideration some pretty basic points, such as load current and load profiles, maximum voltage, system voltage, and possible variations and fluctuations. But for high-speed fuses, that's not enough, really. It's not enough to know just electrical parameters. For a proper, selection and sizing, we also need to know some environmental conditions, so-called. We call them environmental conditions, and then that can include such things as, for example, ambient temperature around the fuse, where it's located, if it's like tight enclosure, if we have or do not have any forced cooling, would it be air forced cooling or water forced cooling? What is a connection size, bus bars or cables? Is it sufficient? Is it not? The altitude of the application can also play some role, frequencies, and many other factors, to be honest, really many factors. It is quite tricky to select a high-speed fuse. That involves a lot of engineering assessment and work.
Right.
Yeah.
So it's not just as simple as looking at voltage and current.
Unfortunately, no. Yeah.
Right. Okay. Well, I'm glad that you guys are the experts, and we can come to you when we need to.
Absolutely.
Yeah. Can we talk specifically around DC and the challenges that that poses in terms of fault interruption.
Yeah, I mean, DC is it's been around. I mean, it's not a new form of electricity. It's been around for many years, but it's being used more and more in all sorts of industries. Battery, as I've mentioned, battery storage and solar is DC, and DC is direct current. It's always on. Unlike AC, which cycles 50 times a second. It goes to a 0 point where there's no voltage or current. But DC doesn't do that. It's always on. I think most engineers would be familiar with it in all sorts of electrical circuits, etc. But the problem with applying it to fuses is it's very, very difficult to break DC. It doesn't want to stop flowing. So if you've got a DC circuit and you decide to switch it off, the switch has to be quite large and very robust, because as you switch the circuit off, the DC will arc much more than it will on an AC circuit. And with that in mind, if you relate that to fuses rely on arcing. And when you try to switch off a DC circuit with a fuse, the arcing is many, many times greater than it would be on AC. So it causes some challenges to our designs, because what we have to do is effectively, if I go back to the model that I had, you can see these restrictions in there. Now, this is an AC fuse. If we were to apply this to DC, what happens is the arcing could jump all the way across and cause problems and not actually isolate the fault, and it can build up pressure and it could explode. So we have to make these elements much longer, and we have to put more of these rows of restrictions in. So what we're effectively doing is dividing up the DC voltage into smaller, manageable chunks. So when the fault does occur, each of these restrictions can handle a small amount of DC voltage, and the process of arc quenching, where the sand is turned into fulgurite, or the fulgurite is the industrial name for the glass that's produced. That occurs, and we can manage the DC arc. But what it does mean is the fuse is much longer compared to, say, this equivalent AC fuse. So a DC fuse tends to be longer because the elements are longer, and the design behind the elements is a little bit more tricky. But it also means we have we have to look at the circuit that it's going on to make sure that the conditions within the circuit are okay for the fuse to work properly. Otherwise, we have to look at different variations of fuses to make sure that the fuse is going to give, one, a long service life, but two, give the best possible protection, because DC is difficult to break, as I said.
So Tony, are you talking specifically about the characteristics of the load? So, for example, the time constant.
Exactly, that's exactly what it is. Yeah, the time constant.
Right.
So on a DC circuit, as if you were to create a short circuit, typically a good example would be a battery bank. A battery bank has an internal resistance. So if you short circuit a battery, the fault current rises at a rate which is related to the resistance of the battery. Now, that can be a long time for fusing. I mean, it can be, when I say a long time, it might be a second or two. But when we look at fusing, we tend to look in milliseconds. So the longer it takes to get up to the fault current, the more heat is generated inside the fuse. The more heat is generated, the less effective the fuse becomes. If it's slowly heating, if it's quickly heated, it operates very, very quickly. So it makes fuse design, fuse selection a little bit tricky. So we've had to adapt some of our designs to cope with these higher DC voltages, or just DC circuits as such.
Right.
But it's not an issue because of our expertise, and because we've invested a lot of money in testing and laboratories in the Burton facility. We can do the testing. So we look at applications, we look at the attributes of the circuit, and we design accordingly, and we produce a fuse, and then we go through a strenuous testing process to make sure that fuse is going to clear effectively under the circuit conditions that we are aware of in that particular application. So if a customer wants a bespoke fuse, we can do that. If they want an off-the-shelf fuse, we can do that. We can test to make sure that it's going to work. So, we're pretty comprehensive, but it does make design and selection a little bit more challenging, but we're up to the challenge. It's not an issue for us.
Let's just turn our attention to. You've mentioned EV applications, and we increasingly on our roads we're seeing more and more EV powered vehicles. We know that there are going to be some challenges around the application of that. I'm not sure whether we've got the amount of time to go into that segment, that application in too much detail right now. But there's also the charging station side. If we turn towards how we actually protect that infrastructure and the charging, what are you seeing with regards to sizing and selection and coordination and standards and so on? So Vasi, I think that's probably one for you to maybe have a stab at.
Yeah, thank you. Electric vehicles or EVs, such cars is a really very special segment indeed, and that deserves its own discussion, that's for sure. And you mentioned correctly, the more electric vehicles you see on the roads, the more charging infrastructure you need to serve them, as easy as that. And there are smaller, let's say, AC charging stations, which you can see maybe on a residential level or on an office level. And dealing with the fuse selections for them is a bit easier for us because it's more, we talk about AC applications. And Tony mentioned that DC, is a bit trickier than AC in terms of fuse selections. So the most challenging part for us within this segment, I would say, is around more powerful or so-called fast charging stations with DC power output.
So are we talking about 800 volt and beyond? Is that where we're?
Yeah, even probably higher, because this segment, on a daily basis requires more and more power. So we talk easily about 1000 volts DC and sometimes even higher. And when we select a high-speed fuse for such applications or for such projects, we usually deal quite frankly with a lot of constraints, and they can include, let's say, proper current and voltage rating sizing because of the increasing power demand, as I said, but also mechanical footprint because people are looking for as compact solution, but also as power efficient as possible. On the flip side, if we go towards bigger fuses with the higher current ratings, that's fine, but then we might violate coordination with other protection means, for example, DC contactors. So the coordination part of such selections is really tricky. And on top of all that, our customers, they want to understand, selected fuses lifetime expectancy, and they naturally want to come up with some maintenance programs for their charging stations. They want to know when they should replace the fuse. Should it be once a year, once in 10 years, how often? And to all set above, also such questions as commercial feasibility, nice and short lead times, compliance to certain standards. That gives you just some grasp of the challenges we or our customers may face during such selections for such projects.
Yeah, I was also thinking about maybe the charging duty cycle as well and the impact that's going to have on aging.
Exactly.
How do you know how a particular charger is going to be used, and what you have to figure out some scenarios and then allow those to be applied and then make some considerations, because clearly people would like to think that fuses are fit and forget, but that's not really the case, is it?
Yeah, you're absolutely right. Yeah, and sometimes that's challenging even for design engineers, because we essentially ask the same questions, but it's very hard to predict. It's hard to predict, for example, electric vehicles load profile, what's going inside in terms of electricity, and power flow. But it's also hard to predict how many people would use this charging station on a daily basis, because if they use it, I don't know, 20 times per day and it's a really hot day, it's really a different situation for the fuse comparing to the cold winter day and just 1 or 2 times. So it's completely different scenarios, and it's hard to predict. Yeah, let's be honest.
Yeah, yeah, brilliant. Okay, I mean, it's really interesting the amount of engineering effort that goes into the making these designs work, but not they have to work, but they have to work efficiently, effectively, in an optimized way.
Exactly.
So I can imagine from what you've said, there's a lot of challenges that you're being presented with.
Yeah.
Just the other area as well that I think we're seeing as we sort of switch towards more renewable is battery energy storage systems. Is that something that you're seeing, and how are you managing those sorts of applications? You know, how can you compare and contrast
Hmm.
what you have to do for battery energy storage versus other applications?
Yeah, 100% energy storage systems, they present another really fast emerging, but also challenging, let's be honest, technical market. And it's mostly dominated by, I would say, battery energy storage systems. As you said, it's a bit different type of applications. And such systems, they can be very complex, and they usually feature, multiple stage design. And hence, multiple stage protection is usually needed for such applications. Maybe we can start with protecting, individual battery modules, and they can be later combined into some battery racks with their own protection. And in turn, multiple battery racks can be combined and put into a single enclosure, maybe let's say a container type. And at the end, it can form quite a powerful application with a powerful output. And this application can, feed into the grid sometimes through power conversion system. Uh, and really, we see cases when every single stage on a module stage, on a rack level, or on the whole system, all the stages, they require different level of protection. And that means different fuses, really, or combination of different protection means or different fuses. And all that, which is really tricky, is expected to be properly coordinated between each other.
Yeah,
It is
yeah. I
difficult.
was I was thinking about that. And what are you seeing the impact of battery construction as well? Is obviously there's the shifts in. Does that have an effect on the way that the fuse has to perform battery construction, or
Yeah,
not?
it does. I mean, there's a lot of different types of batteries out there. I mean, historically, we've seen lead acid and nickel hydride and etc. But lithium ion batteries and the technologies moving forward are a little bit more challenging because um, each of the cells has to be managed in terms of its current in for charging and current out for discharging. Um, so, in some respects, it makes it a little bit easier because the management systems will control how much current can flow each way, which is better for us when it comes to fuse selection because we know a little bit more about what's going on. But the challenge is when, for example, a battery module is connected to a load that we've got no control over. So if it's on an industrial site as a backup supply, the manufacturer might recommend that this battery produce so many watts or kilowatts over a period of time, but it doesn't stop uh, consumers putting extra load on the battery. And if we don't know what that is, that could cause issues with the fuse because it might overload the fuse and we're not aware of
Mm.
that. So we have to build in safety margins to some of our selections to allow for that. Um, but the good thing is, I mean, with battery storage and EVs, we've sort of ridden the wave of technology that's come forward, and we've put things in place in the office so that we've got engineers who can do computer simulations on the element designs and give it different cyclic loading options and see how the fuse will perform under different conditions. So we can put as much as technology and research and development to element design and fuse design as we possibly can to avoid what we call nuisance fuse tripping or issues with the fuse because we want to produce a product that's going to be extra robust. It's going to give a long service life, and we
Mm.
don't want the fuse to be tripping when there's nothing wrong or it's just a little bit overloaded. But we want the fuse to be the fastest, safest form of protection there is. So it's a challenge. It is. But we've invested in research and development to make sure that we can meet these requirements, which is good.
Are you still using? Is it console? Are you still using
I think
console?
we use console, and I think we've got another version now. Yeah, which we use.
So there's a lot of investment that goes on
There is
from an R&D point of view to make the product right first time.
Absolutely.
But also, if a customer comes to you with a specific set of circumstances, you can model the application and really hone in and make sure that the selection's going to be as robust as it can be.
We work with we see it as working with people rather than as a customer. So we want to partner with them to make sure that we get the right sort of product when it comes to design and development.
Brilliant.
And provide all the support that they need.
Yeah. Okay. I think we may have touched upon this, but there's just a couple of other things that I got, which were talking about expected lifetime and technical trade-offs. We may have covered it a little bit, but just if we can just cover the highlights. I think Bassi, that one.
Okay.
Maybe it's something for you.
Yeah, Tony pretty much covered that there are many aspects in applications that can negatively affect the fuses, especially high-speed fuses lifetime. And as I said, it's pretty important nowadays for our customers to understand or to make some predictions, to come up with some maintenance programs, or maybe plan their expenses and downtimes. So it's we understand the importance of this question, and we try to support it, because you saw the design, you saw the internal design of a high-speed fuse. It's really complex, and we touched that there are many factors can affect fuses performance and let's say health, internal health of metals, of elements, and such factors as high ambient temperatures, insufficient cable or bus bar sizing, and other negative scenarios, they can negatively affect, and they can reduce the expected lifetime. Essentially, they can lead to premature fatigue of internal elements, which can lead to so-called nuisance tripping or unnecessary downtime. And to avoid that, we try to apply some safety or so-called derating factors to prolong fuses lifetime, because it's not nice to have an unexpected stop of operation. It can be sometimes very critical, for some applications or areas. So we definitely want to avoid that. But it's hard to predict. So, and again, as I mentioned, if you want to go with a more robust solution, you would probably think, okay, I probably need a slightly higher rated fuse. I need a bigger fuse. I need a more cross-sectional area inside my fuse. But then again, another trade-off, how would it be coordinated with other protection means? Because you may oversize your fuse, and for the fuse lifetime, it's fine. But how well it's coordinated now with your other part of the system, it's a that's a quite a question.
And all the other considerations.
So
brilliant.
Okay. We really talk internally and externally a lot about that, and we really want to support such requests. So as Tony mentioned, we do invest and deal a lot with the testing and simulations and their connection to at least come up with some predictions or estimations to support our customers. So knowing some particular application details, knowing environmental conditions and particular part number of fuse pre-selected for given conditions, we can at least come up with some estimations. Okay, how many cycles do we think in such given conditions this particular fuse could withstand? And this is very valuable, I would say, service that we can provide for our customers. This is really valued by them.
Brilliant. Okay, there's only one other question, and given the amount of effort that goes into designing, a fuse, the quality of a Bussmann fuse, what are your thoughts around the issues of counterfeit, the potential of counterfeit products, Tony?
It's a huge issue. We see counterfeit or lower quality products entering the market all the time, and it's quite scary, really, because as we've mentioned, the amount of research and development we put into these products, we produce, a quality product that's going to work. And these counterfeit fuses, none of that is done. And we've seen them, and we've got hold of them, we've taken them apart, and the designs are quite frankly dangerous. So it's a little bit of it's a bit of a worry, really. So, I mean, we've taken them apart. The elements are poor. The sand fill is insufficient. I mean, these things could really cause some danger or damage to people or infrastructure, etc. It's a problem for us. And the other thing we've seen is that the counterfeiters, they're not very good at designing fuses or constructing fuses. They're very good at making them look real. So you can find a fuse and you'll think it's real. It looks perfectly genuine. And we've also noticed that the counterfeiters will supply you test documentation, which is also counterfeit. So what I say really is, if you buy Eaton product, buy through a guaranteed supply chain. Obviously, you guys, RS Components, are an absolute guaranteed supply chain. And if you buy through that supply chain, you won't have any issues. But if you buy from dubious sources, I would be a little bit concerned. It is a bit of a worry in terms of safety more than anything.
Yeah. So, I mean, we're talking about a safety critical component,
yeah. Exactly.
and it's not something that you should really be gambling on in terms of the supply chain.
Don't take the risk.
So, no, that's great advice. I think we're almost towards the end of the interview. I mean, it's been a fascinating insight. I just want to, we've talked about a number of interesting fuse related topics. We talked about construction. We've talked about traditional applications. We've talked about the up and coming applications, or the not so up and coming, but the applications that you're having to deal with on a day-to-day basis. We talked about some of the challenges around using fuses to manage and control DC, and how that can be mitigated from a design, application, and selection perspective. It's from my point of view, it's leaving me with a very clear impression that fuse selection is complex. But what would you say in terms of recommendations for our audience?
If you are in any doubt, contact us. I mean, one thing we pride ourselves on is support. We don't just offer fuses and put them out on the market. One of the things that we are world leaders at is support. So you are not alone in fuse selection. If you need help, we have dedicated team, and contact details can be supplied, not a problem. Give us a call, drop us an email, and we will go through anything with you. If it's a simple question about fitment, if it's a complex selection, we are, absolute world leaders on this topic, and we will support you all the way. So yeah, please contact us, and we can help.
Yeah.
I think at that point, I'd just like to say thanks everybody for watching. Thank you, Tony and Vasily, for your insights. You're clearly subject matter experts. It's really appreciated that you've taken time to join us today. And for the listeners, if you do need genuine, guaranteed Bussmann fuses, obviously RS has a comprehensive stock available off the shelf. And I'll wish you a good day, and thanks everybody for watching. Thank you.
Thank you.